Welcome to math classes by MDR, so that you are listening to MDR. So here is our fifth question from AP Calculus AB 2021 question paper, and this question is like a cake walk for the students. Really, if you get this type of questions, it means that you are blessed, right? You can see how the question is how easy it is. Okay, let's see that. Consider the function y is equal to f of x, whose curve is given by the equation 2y square minus 6, which is equal to y sin x for y greater than 0. We have four sub questions here. So let's solve one by one. The first one, we have to show that dy by dx is equal to y cos x by 4y minus sin x. So that means we need to find out the dy by dx. That means you can differentiate this equation with respect to x on both the sides. On differentiating, what you get? 4y dy by dx minus 0, and y sin x, we have to apply the product rule, so that dy by dx into sin x plus y into cos x. So let's take all the dy by dx terms on one side, so that 4y dy by dx minus dy by dx sin x, which is equal to y cos x. So on taking dy by dx common here, we will have 4y minus sin x, which is equal to y cos x. So we have dy by dx is equal to y cos x by 4y minus sin x. So one is done. Now let's start with the second part of the question. Write an equation for the line tangent to the curve at the point 0 comma root 3. So we need to find out the line tangent to the curve at the point 0 comma root 3. So when we have a point, we know that, right? What is the equation of the line tangent? So we have y minus y1 is equal to m into x minus x1, right? So let's say that these are the x1 and y1. We have, it is already given, where m is the slope. M is nothing but dy by dx, right? At x1 y1, that is at 0 comma root 3. So on substituting this 0 and root 3 in dy by dx, what we have? So y is root 3 and cos 0 y, and 4 into root 3 minus sin 0. So cos 0 is 1 and sin 0 is 0. So that 4 root 3 and is equal to 1 by 4. So that slope is 4. So what is y1? Root 3 y minus root 3, where m is 1 by 4 and x minus 0. This is your equation of the line tangent. Now let's solve the third one. For 0 less than or equal to x less than or equal to pi and y greater than 0, it is already given anyway, y is greater than 0 for the given function as well. Find the coordinates of the point where the line tangent to the curve is horizontal. Where the line tangent to the curve is horizontal. For horizontal line, so the line tangent is nothing but dy by dx. If it is horizontal, dy by dx must be equal to 0. What is dy by dx? This is what we have, y cos x by 4y minus sin x, and it has to be 0. So that means the numerator must be equal to 0. The y cos x must be equal to 0, and here y should be greater than 0. So y cannot be 0. So that cos x must be equal to 0. So cos x must be equal to 0. Therefore, what are the values of x? For cos x is equal to 0, we have pi by 2, 3 pi by 2, and so on, right? But this x should lie in between 0 and pi. That means we have to take this value, not 3 pi by 2. So that means, so we have to find the coordinates of the point where this line tangent to the curve is horizontal, right? So the coordinates are pi by 2, right? And we have to find out the y as well, right? So to find out the y, let us substitute this x value in the given equation. That is 2y square minus 6y sin pi by 2. So which is 2y square minus y minus 6 is equal to 0, right? So this can be written as 2y minus 3 into y minus 2 is equal to 0. I think 2y plus 3. So that y should be equal to 2 or it must be equal to minus 3 by 2, right? So but here y should be greater than 0. The condition is that y should be greater than 0, so that we have to take only positive values. So negative values so can be avoided, and the coordinates are pi by 2 comma 2. That's it. Now let's put the fourth part of the question. Determine whether f has a relative minimum, a relative maximum, or neither at the point found in part C. So just for your answer. So generally, what is the condition for maxima or minima? If dy by dx is equal to 0, and if you see that d square y by dx square is greater than 0, then we'll have minima. If d square y by dx square is less than 0, we'll have maximum. So let's check this d square y by dx square. So that means we have dy by dx. Taking d square y by dx square from dy by dx, y cos x by 4y minus sin x. I'm taking here dy by dx is y cos x by 4y minus sin x, right? Yeah. Now let's do this. So y cos x, first differentiate the numerator. So we will have, dy by dx into cos x and plus y into cos x differentiation is sin x. So minus sin x. So I'm taking minus sin x into 4y minus sin x, and minus numerator into, so differentiate the denominator, 4 into dy by dx minus cos x. So the whole divided by 4y minus sin x whole square. Okay, so anyway this denominator is always positive, only we need to check that whether the numerator is positive or negative. So for that, let us substitute the values of x and y that we have seen in the part C. So what we have the values of x and y, pi by 2 comma 2. So let's substitute those values. So we have d square over dx square at x is equal to pi by 2 and y is 2. Right, where dy by dx is 0 here, 0 into cos x, I'm not substituting here, so that y. So y is 2 and into sin x, sin pi by 2. So 4y, 4 into 2 minus sin pi by 2 minus y is 2, cos x is cos pi by 2, of course, which is equal to 0. So whatever you have it in the bracket, it becomes 0. The product, okay, this product will be 0, and this is 0 into 0. So minus 2 sin pi by 2 is minus 2 into 8 minus 1, that is 7. So we have something whole square here, and this is 0. This part is 0. Therefore, we have minus 2 into 7, so minus 14 by, maybe you can substitute here, this is 8 minus 1, if I'm not wrong, 8 minus 1 whole square, that is 49. So this minus 14 by 49 is nothing but negative, that is less than 0. So when we have dy by dx equals to 0 and d square by dx square is less than 0, it means that it has relative maxima. That's it. Okay, that's the answer for the part B. Thank you for listening.